Let's move on to the next talk by Pratik from University of Pittsburgh. He'll be talking about trust execution environments and exploring how they impact smart home privacy norms.
Hi. Okay. Am I audible? Yeah. Hi, I'm Pratik, a PhD student at University of Pittsburgh. Today I'll be presenting, exploring the impact of trusted execution environment on smart home privacy norms. So I'll start with the motivation. So IoT devices are evolving on forms, and the platforms are providing numerous integrations. Now this enables IoT devices to share sensitive information over the internet and making a complex task to address privacy concerns and its violations. Now, prior works have studied privacy norms through the lens of contextual integrity. Now, what is CI? CI defines privacy in terms of acceptance of information flows to the contextual norms. And these information flows are described with 5 parameters. Sender, that is the device that is sending the information. Subject, with the person who's getting sensed. Attribute is the type of information that device is sending. Then recipient, with whom the data is getting shared. And then transmission principle is the imposed transfer condition for sharing that information. So in all of this, what are we missing? Well, the backend processing technologies are changing, and they haven't been studied in the information flows, and nor they have been studied for their user acceptance. So with that motivation in mind, we had 2 research questions. The very first one being, does the introduction of trusted execution environments in a cloud-based IoT information flows within a smart home alter the existing privacy norms? And which of the parameters that describe the information flows, that is the sender, receiver, or sensing device, most impacts user sentiments with the introduction of cloud-based TE deployment? And the second one was, do we observe a higher comfort in sharing the information from users who understand the TE's basic principles? Now, the CI framework has been used to measure the information flows and its acceptance through survey, interview, and storyboarding. And the framework has been studied for IoT toys to check for its COPPA compliances, smart home devices for sharing the sensed information over the internet, where the ISP, which is the internet service provider, was able to monitor the data. Or the Google activity dashboards, where users' activities of Google products were logged, and then the user perceptions were studied. And then the use of face recognition in public, and then the user sentiment for notification, comfort, and surprise level was again studied. So we extended the information sharing scenarios as described in 8 by including the parameters of TE and vendor. In this method, we surveyed around 1,049 American adults over 2 weeks on Amazon MTurk. And then each of the participants were randomly assigned to one of the unique group of the 16 combinations generated by group, subject, vendor, and sender. And that is shown in the table. And once these parameters were assigned, they were constant throughout the survey. Later on, we showed participants a video explaining a complete scenario where a face recognition was used by a smart camera to provide home access to the homeowner. And we tried to elaborate on the complete life cycle of information flow, right from the sensing to the actuation of the door lock at a smart home. And then we questioned the participants on the same. We had around 510 participants who answered the information flows with T, and 539 participants who answered the question with T, without T. So with that, as I said earlier, we used CI framework to design our survey. Participants answered questions which were based on Likert scale, and the unique combination can be seen as smart speaker as a sender, established company as a vendor, and the subject was you, and the trusted execution environment acted as our group. The first question acted as our baseline. That means we are not imposing any transfer condition. We are just showing the recipients to the participants, and they're answering on the Likert scale. So the recipients are shown in the blue arrows within the red box. And then the second question was where we inquired with the same combination of the group, vendor, and subject, but with the transfer conditions. that is the transmission principles, and we inquired for every recipient. So in all, we had like a 48 information flows which were answered by each participant. So we analyzed our results between subject with T and without T, and we first evaluated the average acceptance scores and visualized them as a heat maps. Now we observed that with the introduction of T, there is an overall shift in average acceptance scores for all the recipients when compared to without T recipients. And this was across all the combinations of sender, vendor, and subject. And we observed the highest variation for law enforcement, and the lowest one was for other devices at home. Right now, I've just shown for law enforcement over here. Then we performed a man-Whitney U-test that was across the vendors, and we corrected for multiple testing using born-for-any correction. And we observed that T's can help level the playing field between small and established companies. And on the left, you see the butterfly plot for without T, and if you look at the highlighted red box, we observe that the participants are willing to share the information more with an established companies over small companies. And the same can be seen again from the mean ranks, where again the mean ranks difference is also high. But with T, when you again look at the highlighted red box, we observe that there is an increase in comfort in sharing the information with small companies. And again, the mean rank difference has also reduced. And then we performed another man-Whitney U-test across the sender as well. This was our second key finding, that users no longer differentiate between audio and video data. Again, in the red box, if you look at it, the participants were more inclined in sharing the information with smart speaker over smart camera when it came without T. And again, this can be seen through the mean ranks, where the difference was huge. Again, if you look for with T, there is slight increase for sharing the information for smart camera, and this can be seen with the mean ranks as well, where the difference has been reduced. Then we again analyzed our change in acceptance scores for our transmission principles by comparing it to the null transmission. So basically, we are just comparing our second question with our first question, and we used a Wilcoxon sign rank test, and we again corrected for multiple testing by using born-for-any correction. Now, as we compared the change in comfort of sharing of information from the respective baselines, so if you look at the highlighted box, it is for the transmission principle if you are notified. And if you look at the blue arrow right now, it is the change in comfort from the baseline for those without T only. And the baseline scores were lower compared to the T. Thus, we observed that there is a higher need of this transfer condition of notification in the group of without T. And the orange arrow again shows that the change in comfort from the baseline for T information flow was quite small. And thus, it shows an interesting finding that with information flows with T, the users may require fewer notifications in the smart homes. Similarly, we observed that the users of T had a higher comfort in sharing the data for fixed duration. It's again interesting, as it shows that Ts can enable enforcement of data retention, provided device manufacturers and the service provider remain transparent about the practice. But at the same time, few of the key privacy norms remains unchanged, like consent, still very important among users, no matter if the information flows are with T or without T. And storing the data for indefinite time is again not acceptable. And although the bar looks quite big for with T, do note that the baseline scores for with T were also higher. So we inquired participants with the T information flows on understanding of basic principles of T. These included secure storage, remote attestations, and secure computing. And these questions had binary responses, and based on that, we divided them into 3 groups, which is answered correct, the participants who answered all of the questions correctly, answered wrong, who answered one or more questions wrong, and in combine is where we didn't care whether they understood it correctly or wrongly, and so it's a summation of answered wrong and answered correct. We observed that the people with correct understanding had a higher comfort in sharing the information. Thus, we need to make users aware of T. So with that, I'm coming to my conclusion. So with the introduction of T in smart home information flow, it's beneficial for the users as they can have a greater choices of devices, as the users do not have to rely on name brands for his privacy concerns. Like basically, they don't have to rely on Google or Amazon. No offense to Google or Amazon. As T reduces the differentiation between the sender, or there is a reduction in requirement of notification and improves the sharing of information in limited retention. It provides device manufacturers and service provider a unique opportunity to provide users with the new utilities, new sensing platforms, at the same time having fewer notifications. All the stakeholders should understand that the user's core privacy principles cannot be altered by adding or improving a tech. And this can be seen with the introduction of T. Certain privacy norms remain unchanged, like consent and indefinite storage. And there should be, like, the privacy regulations should respect the users for these two principles, for sure. And now we have studied T's only with a cloud-based model, and the evaluations of T for other models needs to be studied for users' perceptions and expectations. And these placement of T's can be included like on-device, fog, or edge, or there could be any permutations and combinations of these. And to further validate our results, in the future, a longitudinal diary or a log study or a qualitative interview will be required. Thank you. Any questions?
We have a question online from Smriti. How did you test the internal reliability of the survey questions, and what was the process of drafting the survey questions using contextual integrity?
So we used a Nissenbaum's theory for designing these questions, and her first part was, I missed the first part. I understood the second.
The first part was, how did you test the internal reliability of the survey questions?
So to test the internal reliability, we used a we use some attention check questions, whether the users are deviating or not, and whether they're understanding the survey or not.
The second question is, it would be interesting to understand to what extent regular non-expert adults understood what the concept of TEs actually means. Like, for example, guarantees by hardware vendors and so forth. And whether TE was perceived more as an extra layer of security by the users.
Yeah, that's right. That's the reason I said, like, we need a further analysis on qualitative interviews, because as this was an MTurk survey, there's limitations on what quantitative analysis could do. So that's the reason we said, like, to further affirm our results, we need to do a qualitative interview or a diary or a log study to see how it goes.
And I have a question too, like, you have prepared descriptive videos to explain how these trusted execution environments work, and still a sizable portion of users couldn't understand them or understood it wrongly. So based on your expertise, like, how can you explain TEs to a normal user who is not knowledgeable in this space?
Maybe by having more animated videos. Like lately, there has been an Etsy, where they said, like, if people are not able to understand, then design some good anime or a video kind of stuff, and it helps them, like a layman person, to help. Cool.
Thank you. Let's thank the speaker again.